Have you ever pondered the nature of reality? Does quantum mechanics, the theory that governs the tiniest particles in the universe, hold the key? How we perceive reality might in fact be influenced by the quantum world, a realm that defies our everyday logic and understanding. Quantum mechanics, a cornerstone of modern physics, provides us with a mathematical description of the wave-like behavior and interactions of particles. Central to this theory is the concept of the wave function, a mathematical function that describes the quantum state of a system. It's the wave function that allows us to predict the probability of a particle's position, momentum, and other physical properties. However, despite its prominent role in quantum mechanics, the wave function's true nature has been a subject of much debate among physicists. But here lies a conundrum. Do these wave functions represent something real, or are they just useful tools? A recent survey of over 1,000 physicists revealed some startling divisions in the field. The world of quantum mechanics, it seems, is as complex and unpredictable as the particles it studies. This survey, conducted by Nature magazine, brought to light the varying perspectives and interpretations that exist within the field, particularly concerning the wave function and the boundary between the quantum and classical worlds. The wave function, a mathematical description of the quantum state of a system, is a topic of much debate. Some physicists see it as representing something real in the world, while others view it as merely a useful tool, a means to an end in calculations and predictions. This division of thought reflects the inherent uncertainty and ambiguity of quantum mechanics, a field that thrives on the edge of the known and the unknown. But the disagreements don't stop at the wave function. The survey also highlighted differing opinions on where the quantum world ends and the classical world begins. This boundary, often referred to as the quantum classical transition, is another area of contention. Some physicists argue for a clear-cut boundary, while others contend that the transition is more of a gradual shift than a hard line. Amid these divisions, the survey revealed an unexpected undercurrent of uncertainty. Many physicists admitted to a lack of confidence in their favored interpretation of quantum mechanics. This suggests a field in flux, one where even the experts are questioning and reevaluating their understanding. Despite these divisions and uncertainties, one interpretation of quantum mechanics remains dominant: the Copenhagen Interpretation. Proposed by Heisenberg and Bohr, this interpretation views quantum phenomena as practical and often taught. Yet, it is not without its criticisms. Some argue that it allows physicists to avoid grappling with the deeper, more philosophical questions posed by quantum mechanics. The Copenhagen Interpretation, despite its criticisms, remains the most popular view. But why? As we delve deeper into the world of quantum mechanics, we'll try to unravel this question and more, so stay tuned. The Copenhagen Interpretation, proposed by Heisenberg and Bohr, has dominated the field for decades. This interpretation has been a mainstay in the realm of quantum mechanics, largely due to its practical approach. Rather than getting mired in philosophical debate, the Copenhagen Interpretation focuses on the tangible, the measurable, and the observable. At its core, the Copenhagen Interpretation suggests that quantum phenomena don't have definite properties until they're measured. In other words, a particle exists in all possible states at once until observed. This might sound like the plot of a science fiction novel, but it's the reality we grapple with in the quantum world. This idea is encapsulated in the famous thought experiment of Schrödinger's cat, which is both alive and dead until observed. The Copenhagen Interpretation remains popular because it's practical and easy to teach. It doesn't require a deep dive into the philosophical implications of quantum mechanics. Instead, it allows physicists to deal with quantum phenomena in a way that yields predictable results, making it a useful tool in the toolbox of quantum physics. However, this practicality is also the source of criticism. Detractors argue that the Copenhagen Interpretation allows physicists to sidestep the fundamental questions that quantum mechanics raises about the nature of reality. By focusing only on what can be observed and measured, they argue, we're avoiding the deeper, more complex issues at the heart of quantum mechanics. For instance, if a tree falls in a forest and there's no one there to hear it, does it make a sound? The Copenhagen Interpretation would say that the question is irrelevant. It's only concerned with what can be observed and measured. But is this a satisfactory answer? Critics would say no. Yet, the Copenhagen Interpretation's dominance doesn't mean the debate is over. Despite its popularity and practicality, the Copenhagen Interpretation is not the final word on quantum mechanics. The field is still rife with debate and disagreement, and the quest for understanding continues. As we delve deeper into the quantum world, who knows what we might find? The debate about what quantum mechanics says about reality is far from settled. The world of physics is still grappling with interpreting the enigmatic field of quantum mechanics. Just as the quantum realm is a place of inherent uncertainty, the debate surrounding it mirrors this ambiguity. The interpretations of quantum mechanics are as numerous and varied as the physicists who study them. The Copenhagen Interpretation, the most popular among researchers, views the quantum world as practical, a tool to be used rather than a reality to be understood. However, it's been criticized for allowing physicists to sidestep grappling with the profound philosophical implications of quantum theory. Despite its popularity, the Copenhagen Interpretation is not the only game in town. Other interpretations, although less popular, offer their own unique perspectives on the quantum world. Some propose that the wave function represents something real, not just a useful tool. Others argue about the boundary between the quantum and classical worlds, asserting that this border is not as clear-cut as we might think. What's fascinating is that this debate is not just about abstract philosophical questions. It has real-world implications for how we understand the universe and our place in it. For instance, if the wave function represents something real, it could radically change our understanding of reality. The fact that many researchers lack confidence in their favored interpretation underscores the complexity of the issue at hand. It's a testament to the profound mysteries that quantum mechanics presents and the challenges that physicists face in trying to unravel them. In many ways, the ongoing debate is a testament to the vibrant, dynamic nature of scientific inquiry. It's a reminder that our understanding of the universe is always evolving, always in flux, just like the quantum world itself. As we delve deeper into the quantum realm, our understanding of reality might shift dramatically. Are you ready for the quantum leap?